France is really pleased to have Glenn House talk today. Glenn House has been a CEO and president of a large number of large companies, and you can go to his LinkedIn page and you find a great description of all the companies. What LinkedIn doesn't tell you that he's been doing Lisp since he was in college, and as he said himself, learning Lisp completely destroyed his capability to program in any other language. So after about 8-9 years ago, he was done with doing large companies, big companies, and he started his own company with a friend, and he decided to be a complete Lisp company. So he developed a whole range of Lisp products that he sells in the enterprise, mostly in the defense industry. And he actually has given talks about these products at various Lisp conferences. And right now his company is growing, and he's got some really interesting products, and he's going to talk about some of those products today in this talk. So Glenn, please take the floor.
Okay, thank you, Jans, for that introduction. I appreciate it, and welcome to everyone who's on the call. If you're in the East, good afternoon, and if you're in the West, good morning. I'm going to talk about driving operational support for the U.S. Department of Defense in its supply chain. The focus of what we do here at 2Eyes is we were established in 2002 fundamentally to be able to connect small to mid-sized manufacturers with the Department of Defense $40 billion need for repair parts and consumables. And we were focused on really delivering end-user product to the market space. And during that period of time, as we started to develop mechanical parts, mainly mechanical parts and some electromechanical parts, it became clear to us as the government started to implement SAP, large-scale ERP, that the problem that they had was not only procuring parts, but also being able to rectify or reconcile and rectify a number of embedded inefficiencies in their databases. A lot of these databases are legacy databases that go back tens of dozens of years. You probably are unaware that many of what we would call weapon systems, which are tanks and trains and airplanes, their service life is well over in the average of 30 to 35 years. And so when you have assets like planes and tanks and submarines whose useful life far outstrips its production time frame, the need for spare parts is immense and difficult, because you have, where do you go get a part? You know, if you need a drain or a pump, you know, for a Trident submarine, it's very difficult to procure. And as a result, the entire infrastructure of information becomes very convoluted. So in this environment, this is where we started to think that the government could profit from what we call decision support tools. And decision support tools are tools that really focus on helping subject matter experts and daily operations managers make decisions for inventory in our particular case. Now you might say, well, SAP is exactly doing that because it's an ERP system. Well, an ERP system really is all about accounting and keeping the accounts correct and keeping the various different parts of supply in check with the accounting records. The problem is that when you start talking about millions of parts, and each of the parts have dozens and dozens of pieces of metadata, and you have distributed warehouses all over the world and distributed transportation, many different things will get out of sync that the ERP system keeps records on, but doesn't necessarily keep reconciled. So with that overview here, I'm going to talk a little bit, I'm going to start my presentation. This is what we call a 5P frame, and it helps frame what we're really trying to do here. And let me talk a little bit about the product in the upper left-hand corner. It's an inventory manage and decision support tool. Okay, it acquires, scrubs, and validates data from various sources. And many people think of an ERP system. They might think of an ERP system as having one source of data, and that's definitely not true. There are many different sources of data, which include the fundamental relational tables, and maybe even a business warehouse. But there is also many different legacy databases out there. And in the case of the government has legacy databases going back that were generated with COBOL, old codicil, and they could range from flat data files all the way up to modern relational tables that are accessible with ODBC and so forth. But the bottom line here is the user or the person who's requiring decision support doesn't want to have to deal with all those. They want one place that they can go where they can basically approach the problem and see all the data that's relevant to what they're trying to do. And we call that a low-click interface. And there's been some tests that we've performed that would indicate that, for example, to get any particular piece of data that you really want to get out of SAP that's relevant, you'd have to have somewhere in the neighborhood of 12 to 24 clicks, mouse clicks, to go to the right screens, provided you even knew what the right screens were to get there. And this is a big problem, not only for large-scale data, but also for folks who are coming up the learning curve. The other big issue is that it has to be DISA compliant. It has to be in a secure environment. It has to meet rigorous information assurance requirements, and it has to be able to hang into the government infrastructure without actually penetration. Although the data itself is not secret and is unclassified, the data taken together as a whole is sensitive, and so we have to provide protection for the data that's up to information assurance standards. The other thing that we wanted to do here with the product is we wanted to structure it as software as a service. We wanted, because not only is it a model here that is in vogue, it actually really does fit the implementation of what a decision support tool is trying to provide. Software as a service gets wide accessibility, as long as you have authentication. It allows you to maintain a single instance of the software, so it allows us to be nimble and quick in terms of updates. All of you are probably very familiar with the benefits of software as a service, but as a decision support tool hanging on ERP, it's relatively new because this is actually in the intranet instead of the intranet. And we've been able to do that. And a little bit later, we'll be seeing a demo of this, so you'll understand what it looks like coming across the internet. Our primary focus on placement in the upper right-hand corner is, initially we decided to take the OASIS product into the military as technical and economic buyers, and the military centers, and also large OEMs who are basically dealing in the military commercial market. You probably could name them, but I won't name them by name, but there are big OEMs, 30, 40, $50 billion companies who make their living in the military supply chain, in the military products. Where 90–95% of their business comes from the military, and this is an ideal application for them as well. There is also some commercial use for this that are non-military companies. We can talk about that a little bit later in the presentation. But the basic focus and thrust is in the people who have large-scale consumable parts needs or inventory needs, and that their serviceable available life is a lot longer than the production lifetime. You could see this in tractors. You could see this in tractor trailers. There's many different segments in which this would be valuable, and that an ERP system would be valuable. Now, it turns out that we've built this around SAP, but you could just as easily be drawing data out of Oracle's or out of Sybase or out of any other ERP system that or even a homegrown SAP system. Our promotion is very, very simple. I think, like most companies, focusing on testing and validation and convincing the customer that we can handle their large-scale databases. We get, I think, a common question is, and we're going to get to this in Lisp in a moment, is, yeah, but our database is really, really big. Okay, and usually my response to that is, yeah, how big is it? And I say, well, it's millions and millions and millions of stuff. And, we really have to demonstrate handily that we can handle millions of pieces of data, basically hundreds of millions of instances with basically billions of atomic pieces of data. And that's not a problem for us with AllegroCache. We've used AllegroCache for many, many years here, and we can really very, very quickly dispense with any conversation about, yeah, but our data is really, really big. Okay. Usually that is quenched within the first hour once you start talking about it, and then show them a demonstration. Our price to performance in the bottom left-hand corner is we really want a high-performance compute environment decision support system at a very reasonable price. And this is another reason why we use software as a service, because it allows us to reduce the total cost of ownership to the customer, where they don't have to stand up hardware, they don't have to stand up a support staff, they don't have to stand up, all of the internal IT things, including IA and all these other parts of their base in order to support OASIS. Basically, a customer gets access, they log on, and they're ready to go. Okay? So our value proposition here for OASIS is economical data-intensive inventory management decision support systems validated by DOD and major commercial customers. Important words here are, data-intensive, large-scale data, validated by DOD. Okay, so the solution you're seeing is a solution that has been validated and is in use in the DOD. Okay, let's talk a little bit about the intellectual objectives that we wanted to achieve here with OASIS. Many of you are probably familiar with the concept of the wisdom pyramid, where at the very bottom you have data. Data is basically discrete objective facts, and it's sometimes called metadata, depending upon if it's data about data. And people are drowning, just literally drowning in data. They have so much data they don't know what to do with it. Everybody tells them it's an asset, but they don't know what to do with these assets, and they keep looking for more and more commercial tools to deal with it. And what they want to be able to do is they don't really want the data. They want to go up this pyramid, and they want to convert data into information. Okay, data in context is information. So you could think about the number 27. That's a piece of data. 27, which is the number of outs in a baseball game. That gives you some data in context, right? Knowledge is basically all about subject matter expertise, right? There are people in the subject matter, in whatever kind of area you're talking about, in our case, inventory management, that are subject matter experts. They know what the data means. They know what the relationships are. And what you have to be able to do is you have to be able to take subject matter expertise, and you have to be able to flow it out to the masses. And this is a large problem, okay? Because in general, getting in a large organization, you could probably count your subject matter experts on one hand. If you have a 1,000-person, 2,000-person, 5,000-person organization, and you have maybe a handful of subject matter experts, but you have 10 dozen people who need that expertise. And so part of the objective with OASIS is to be able to take subject matter expertise and flow it out to everyone else. And then once you have the knowledge flowed out to everyone else, those people need to be able to do something about the problems that they perceive. Okay, and that's where wisdom comes in. One, people have to know what to do. And so if you look at on the left side here, I put it in more database terminology that that folks who are developers and programmers and so forth are probably familiar with. You can see the extract, transform, and load and profiling of data and parallel ETL is at the data level. Scorecard, forecasting, inventory modeling, and the like, where you're performing algorithmic computations on the data, is really about creating information. Okay, being able to execute expert rules and rule systems on the information is really about knowledge, and then condition correction. Once you've found the errors, how do you fix them, and how do you get them resolved? That's all about wisdom. And that's the way we've structured OASIS. We have some technical principles that we put in place, and I want to talk about those because those are as important as the architecture, which we'll get to. The first technical issue that we really wanted to address here is that we wanted to develop the government really wants to see companies who have developed with a defined software model. We developed in accordance with CMMI capability model. We are a level 3 audited and certified software development organization. I would add that we're not certified simply because the government says we should be. We are audited and certified because it really brings a level of quality to our product that we find to be very, very important. And as a small company, we can't afford to have a lot of customer support, and your best customer support is a high quality. We've actually created a customized model that has been audited by the CMMI organization, which is a hybrid model between Agile and Waterfall. And we are in the process of seeking level 5, and we would like to seek the end of the level 5 certification by 2012 or 2013. We're actually performing at level 5 today, but it takes a couple of years of performance at that level before you're ready to be audited against that capability. So in summary, we take this our process very, very seriously here at 2Eyes. The second point I'd want to make is we have this concept that it's very difficult to maintain, but it's important, and we have avoided many, many defects. It's called one data, and that means that data has a single golden root, and all references and replications must stem from this root. We don't allow data to, and we systematically remove anytime a piece of data is copied somewhere and then there's a reference to the copy. So we don't allow that. If you're going to create a copy of data for use, it always has to be one level of hierarchy. It always has to go from the golden root. And what this means is that as we build out our system and as we expand our system, we're not chasing our tails through a complex web of data. This has driven our architectural changes and our architectural decisions to a large degree, and this allows us to fundamentally understand the nature of where data needs to be changed. Because one thing that you need to have in a system like this is the ability to change data rapidly and change its definition rapidly as your customer changes their definition. And you can't go to have one piece of data referenced which is in 5 different places and then change it and keep it consistent. You have to have a single origin. We also focus on factoring out building blocks so that we can use them in multiple products, because this allows us to keep a high degree of quality. And the last issue of quality, I'll say it again, quality is our first line of customer support. It keeps our customer support costs way down and way in the bounds of affordability. Our technical objectives in OASIS were really, we wanted architectural scalability, hundreds to thousands of users, and we wanted to be able to handle millions and 3 to 5 million national stock numbers, or if you were talking in the commercial market, SKUs. We wanted to have superior usability. We wanted to have speed in realizing functionality. So we don't want our customer to come to us with a functionality request and we tell them that it's going to be 18 months to get it. and we don't want to have releases that last 9 months. We want to be able to move through a quick, very streamlined software process where we can respond to customers' desires neatly and with a great degree of quality very, very rapidly. The other thing we wanted was security and information assurance. The government, as probably you're aware, is very security-minded. All the government folks have what's called CAC cards, or Common Access Cards, and so all of our software is CAC enabled, and so we didn't want to have CAC enabling in every one of our applications, and we have half a dozen applications. So we built a front end, which we call the user environment, which basically handles all of our security and information assurance needs and handles CAC cards, as well as passwording into our system. We wanted straightforward extensibility because as the customer learns more and more about their big data, we want them to be able to push that knowledge into OASIS without a developer being present or being required. The other thing that was important for us is we wanted no footprint within the customer's walls. In other words, we didn't want to have to go to the government and say, okay, you have to buy 27 machines and 14 IT people and a bunch of other people to do that. So what we've done there is we have articulated that it requires no footprint within the customer's walls. Now we get into Lisp. Why did we choose Lisp? All right, on the right-hand side here, you'll see a graph that I've lifted out of a paper that was done in 2000 by JPL under some work that was defined by NASA. And it's very clear here, and we have found this to be true and unassailable. It's very true. If you look at Lisp versus Java or C++, Lisp is basically as good or better in runtime. It is good and better in final image size. This is it's comparable. It's a little bit bigger than C, but at this point in the life of disk size, who cares? And it also has the development time is on the order of 4 to 5 times faster. What this translates to is I have a smaller team, and I'm able to keep better handle on quality with fewer defects, okay, and be able to handle a wider range of functionality. Lisp just basically takes that apart, those tenets, and just drives them home, okay. Yeah, you can argue about all the various different pieces of languages that are all seeming to grow up organically like dandelions all over the landscape. And I don't want to get into religious arguments, but at the end of the day, what really matters is how much does it cost you to build the application and how much does it cost to support it. And Lisp gives me the ability to do both very economically. CLOS is a fabulously flexible object system, and the benefit of CLOS is really enhanced with AllegroCache. AllegroCache allows you to basically work with object-oriented as an extension, almost seamlessly an extension of object-oriented. It's a brilliant implementation that it even goes beyond simple. Okay, and it takes one line of code to make it take an object and make it persistent. And if if in the AllegroCache environment, when you want to change something, if you have millions of records and you want to add another field, it just you open up the database and hit Control E and it's done. And then you use commit. I mean, it's beyond. There's an elegance and a simplicity to it that is nothing more than genius. And so it allows us to have developers who say, oh, I don't have to really think about the implementation of a database here. I can think about the schema, and I can think about what I'm trying to achieve. And this is the fundamental beauty of AllegroCache. We also use AllegroServe, and we also use Web Actions. So it's probably time that I tell you that 100% of our system, from the back end to the web server to the front end, is Lisp. The only thing we don't use that's in Lisp, which is in JavaScript, is our widgets that are on our pages, which are we use a little bit of JSON here and there as an interface standard, but we use jQuery as our fundamental widgets. But this is a 100% Lisp environment. That also helps us in terms of information assurance, because we don't have to worry about all the, SQL injection and all the busy little guys who are trying to figure out how to beat Oracle and all those, because they can't get by all the Lisp stuff. It just doesn't happen, and they get, we have been able to really be a game changer there. And of course, Web Actions, which is something that Franz has developed but put into the public domain, is the ability to separate the user interface from the implementation, and we've used that extremely successfully. A little bit about OASIS architecture. OASIS really has 5 different things in it today. It has a population explorer, an NSN explorer. It has the ability to look at scorecards. You want to understand how a population is scored. We have a rules-based engine, and we do workflow. If you think about a population of parts for a moment, think about a population as parts as like all the parts in your Honda Civic or all the parts in your dishwasher. So you want to manage all the parts in, say, your dishwasher as a fundamental unit, right? But probably some of the parts that are in your dishwasher are also in your trash compactor, right? So they can share parts. So you have this concept of populations of parts, right? And you can see how that would apply in the government area. You might have a tank, right? But there's the Abrams tank, for example, and there's the Sherman tank, and there's the X tank, and the Y tank, and the Z tank. But some of those tank parts are made by the same vendors or different vendors, and they're shared among them. So what you have to do is you have to create populations of parts. Once you have a populations of parts, you want to talk about a particular NSN in that part, or a national stock number, or for the people in the commercial area, a SKU, and you want to be able to know a lot about that part, and you want to be able to look at the metadata around that part, the management data, the stocking data. Where is it? How much do I have? How long does it take to buy, for example, are pieces of metadata. Another piece that we have here is rules-based exceptions, which is, these are rules about inventory. So, for example, if you have a back order, but you have stock on hand, that is a fundamental contradiction. You shouldn't have stock on hand if you have back orders. There's something fundamentally blocking the ability of the stock on hand to fulfill the back order. Now, there could be many legitimate reasons for that, like, for example, a management hold or a quality hold or a whole variety of reasons, but there are some other reasons why you might have stock in inventory and not be able to fulfill a back order. For example, what happens if you have stock in transit from place 1 to place 2, and you have a back order, and its transit time is 2 months. There's a good example of stock on hand in which you can't fulfill the order, and so forth. So we build these rules. Subject matter experts will build rules to say when are these things that should not happen versus those things that are allowed to happen. Workflow is another piece that's built into OASIS, which allows users to basically look at data that goes through all the process. And we have built through a scalable architecture. We can scale data, and we can scale users. The architecture that we've used here for Lisp really gets down to what we call a framework type of architecture. A framework architecture where we have an extract, translate, and load on the left side, where we take data that comes out of a variety of databases, we scrub it using ETL techniques, and we normalize it into a data definition. We then basically apply a number of different things in our system that help us be able to distribute and allow us to calculate all the things that we need to do in a very efficient way. We use Lisp, and we've developed a distributed analysis and cruncher. We call it the DAC, which is essentially something that allows us to take millions of NSNs or millions of stock numbers and throw it out onto a bunch of different computers and compute all of the various different things simultaneously. Okay, that has been a very, very big benefit to us because we're able to compute all of the things we need for the entire government database in about an hour overnight versus what it would take SAP days to do, and that has been very valuable to us. So one of the things that I talked about a little bit before is AllegroCache. AllegroCache is really an enabling technology for us. We wouldn't be able to do this without a persistent store. And many folks ask us when we talk about it, why didn't you use Oracle? Why didn't you use a standard relational database? And the answer would be, well, quite simply, it would be very expensive, if not impossible, to deliver the kind of product that we're dealing with in some economical market window and cost envelope that is necessary to make money. All right, and most people kind of their eyes shoot up in the air when I say that. I'm saying, yeah, you can do anything you want with a relational database if you have enough money and time and people. And unfortunately, in a small to mid-sized company, you're constrained by all three. So we've been using AllegroCache now for 3+ years. We actually started using AllegroCache before it was 1.0. Developed by John Fodoraro here at Franz, and over the years we've seen it develop into a more and more powerful tool. It's object-based, so it's a simple extension on object-oriented programming. We've already talked about that. The thing about it is it allows us to model data and incorporate legacy data in a very, very simple and a very, very economical way. You simply can, in decision support, you always get new data. Your subject matter experts discover new rules, new things, and they want to incorporate new refinements into the data model. And you can do that very simply by extending the classes, the object-oriented classes, and you can preserve all the existing data that's already there. And in a relational database, as many of you have worked in relational databases know, that as you add more and more complexity to the relational databases, it becomes a rat's nest of arrows and connections and indexes. And we have just found that, by using as an extension of object-oriented database, it's just object orientation, I'm sorry, it's just very simple to understand and maintain and extend. We do not have to perform gymnastics, okay, or relational gymnastics. And now, we have, a lot of people also ask, well, what about, RDF and all this new technology that's coming on the market? And we think RDF has a great future, and we're actually looking at AllegroCache for some large-scale unstructured data mining. So we think that the family of tools, AllegroCache and AllegroGraph, have tremendously long legs and a lot of viability in the big data marketplace. So with that in mind, I'm going to give you a quick demo here of OASIS. And here you see our user environment. Our user environment is a program that allows us to hang our various different tools off to the user and have a common sign-in paradigm using CAC. And here you can see that we have 3 here: AutoPrice, ESP, and OASIS. What you see here in OASIS, this is our startup screen, and you can see that the various different things here, the Population Explorer, the NSN pricing, Expert tab, Report card, Workflow, some messages. The first thing we're going to do is we're going to go into the Report card, and we're going to look at, and here are some populations that I talked about before. You can see here that here are some C and E populations. Here are some Susan's NINs, right? This is 270 NSNs. This one is 64,000 NSNs. And what you have here is you have a grade. The grade is how well are all those NSNs over its entire population. So here you can see that C and E has a population grade of like 67%. What that means is that, essentially 33% of the NSNs, or the stock numbers in that population, have some priority 1, okay, rule violation. All right? Well, it doesn't take a rocket science to say if you have 30% of 64,000, that's a truckload of problems. Okay? And so you say, okay, well, let me go off and let me take a look at one of those populations, okay? And you can say, take a look, and here are the different rule groupings. Each one of these is an individual rule, okay, that it violates. And you say, okay, well, let me go take a look at this population. And these populations are, and you saw how it's downloading over the web to a variety of NSNs that are in this population, and there's 4,813 NSNs in this population. And you can see that they have a whole variety of metadata, right, that stems from management data to pricing to how many are on hand, how many, what's the reorder point, how many are due in. This is all stocking information. Now, say I don't want to deal with 4,813 NSNs. I can subpopulate down and get to a smaller population of NSNs and say these are the populations that are the high demand items that I want to really look at and I really want to focus at. And then I want to be able to have a user experience where I want to move the columns around because this is the way I particularly look at this. Now recognize that this is all happening in an Internet Explorer on the user's desk, and you basically are it's happening in real time for the user using a distributed environment. So the users it looks and it feels like a desktop application. That's another important part here. We wanted an user experience where it looked and it felt like a desktop application that was being delivered over the web. You can get information about data, okay? You can get stocking information. This is all the units that were ordered, the 36-month demand. You can get all kinds of information about charting. You can look at the weapon systems. And then you can, of course, drill down into a specific stock number and ask, what is the administrative lead time? What is the production lead time? How many on hand? How many are due in? What is this? This is all stocking information. You can look at the forecast, how many we're forecasting, how much the government is forecasting. All the data is basically one click away, and it's easy for the user to basically be able to see all the particular data that they're interested in. What you're seeing here is the rule violations that are important to the user. We talked earlier about rule violations, and here what we're doing was we're showing all the rule violations for these 7 NSNs. Now we could have done it for 3,000, 10,000 NSNs, but here you can see that this NSN has existing back orders, right? This NSN has back orders of all sources that are greater than 0, right? And we need to expedite PRs, and we have to do all of those things that are necessary. The user will now understand what they have to do there. And we have some number of 88 different rules, and these rules are not controlled by us as developers. They're controlled by the user, because it's important for them to be able to handle their own rule set that's particular to them. Now, this is OASIS, and this gives us the ability to really visualize and amalgamate and combine all the data together. One important part of OASIS that we've talked about is we've talked about the rules. And I want to show you one thing, which is you want to ask, how do you get rules out of the hands of the developers and into the hands of the subject matter experts? Well, we built a tool that we call ESP to do that, and I'm going to bring up ESP and show it to you here. ESP is a visual graphical environment for capturing rules from the customer's data. And what you're looking at here is the capture of a rule, which these are our rules over here on the right-hand side. And what we have done is we have created an environment, a development environment, if you think about it, that allows you to have operators, data elements which map to the data elements that come into our OASIS program, complex variables, which are essentially functions that are necessary to do complex calculations on the data elements, and preferences, which are allowing users to change external data items from the program, and allow them to create rules in a drag and drop environment. Here you're seeing just an example of somebody creating a rule where we're creating a rule that you have to have at least 24 months of demand, has to be greater than 0. You would drag an operator. You would say, well, what we really want to have is we want to have the time to buy be less than some number and 0, and that means that they missed the time to buy. And we can say we want to be able to say anything that is less than, we've missed the time to buy, we want to know about. It's a system where we have revision history. We also can do testing. So, for example, when a subject matter expert creates a new rule, you want to know, is it any good? And we allow them to do testing on the rule set and using the populations that have been defined in OASIS so that they're familiar with it. In this way, we basically externalize all rule development by the customer, and that allows us to make it a very powerful environment for a subject matter expert to go. I'm running a little long here, so let me get down to the business. One question is, well, so what has the results been on this project? This is a study. I've blacked out a couple of things to protect the authors, but this is actually 3 slides that came out of the Defense Logistics Agency on OASIS, and you can see here that in the first case, there were 214 stock numbers that had potential annual losses of over $100,000. That's $126 million, okay, of losses that were presented for review, okay. There was, in the second case, there were 236 NSNs that had potential annualized losses of greater than 100,000. That's $181 million in potential annualized losses that was reviewed. It was reviewed as an audit tool. So you're basically looking at 10 NSNs, 10 stock numbers that were updated during the test will avoid tens of millions of dollars in fiscal year 10,000 losses. That computes to a return on investment for the government for this tool as like 15 minutes, okay? The government saw that this pricing tool would identify anomalies that were not visible with the SAP system, and it organizes the NSA in a way, NSNs for review in a make sense, understandable way that's population based, and it improved their productivity and productivity from 12 clicks on average to 1 click on average. OASIS does the math for them, so they don't have to think about it, and it gives them case studies and just-in-time, on-the-job job aids, so that it's straightforward and it fits the task. This is what our customers are saying about the tool. And again, I emphasize this is in Lisp, right? So, for once and for all, I'm happy to have nobody talk to me about Lisp and start talking to me about what the technology can do for them. The last thing here is their recommendations, and this was a year and a half ago or a year ago, was transition from R&D into production and to expand the extract to support NSNs with demand. We are way beyond that. We're already well over 1 million NSNs in our database that we're computing on a daily basis. So at the very end of the day, in summary, we've got a complete Lisp system here, built on top of AllegroCache, which I really can't say enough about, and delivering substantial, incredible return on investment for our customer. With that, I'll stand aside, and Jans, if you have any. If you want to take over now, and maybe if there's any questions.
Yeah, there's a few questions. Some of them from the people in the audience, some of them from me. So one question, I would like to start with a question that I have. That is, to what extent can you use this tool outside of the defense industry? I mean, is this very specialized, or would it be easy to use it in other domains?
It would be very easy. I mean, the way this is the OASIS has been structured, it's structured in such a way that it's a very general tool, and all the nomenclature that I've been talking about during this presentation is easily changeable, because what we've done in the tool is we've developed a backplane, and this backplane defines all of our data definitions, and you can think of OASIS as a vessel that allows us to import arbitrary data into our decision support capability. And it wouldn't really matter whether it was military or commercial. It's as long as we had data in whatever form, we could slice it and dice it, get it, normalize it, get it into OASIS, and then apply our technology to it.
Okay, so another question is kind of related, and that is the rule tool that you showed looked very interesting. To what extent is it just a general tool that you can point at say, a clause and it will work, or was it to some extent specific to your SNNs? I mean, the terms on the left-hand side
Exactly.
look like they were trained for that particular database, but I mean, can I use it for any class or maybe even a AllegroGraph database?
Yes.
If I wanted to.
Yes to the last. It's a very general piece of technology that takes in data definitions and then allows you to write arbitrary rules. We actually, in one of our tests, we actually wrote it so that it actually does stock picking on the NASDAQ. Okay. You know, so it can actually identify expert system violations on NASDAQ data, right? Stock trading data. That's one of our. We also one of our other demos is to show how developing nations. We use United Nations data to show how GNP, those countries that have abnormal GNP anomalies. So it's a very general piece of technology, and if you look on our architecture, you'll see that it's a block, which means that it just happens to be applied to this inventory application. We've also applied it to data scrubbing, right? Data or data quality problems. So there is a number of useful uses for the expert system that lie outside of OASIS domain.
Yeah, Craig and I might come back to you and ask you to do just a whole talk just about this rule system. It looks very, very interesting.
Well, by the way, that's that all is when you were seeing that demo. That's all done over the web. That's all jQuery and in the served over the web. All that drag and drop interface was done by our developers.
Yeah. Okay, another question. So, what if you have to? I mean, you're growing and your business is going well. So, how do you deal with hiring new programmers? What kind? I mean, how do you get them? Is it hard to get them?
It's challenging to get new programmers, but one of the things that we have done, and I think we've changed the focus, and not to anger any computer scientists out there, we have taken to hiring primarily mathematicians, and then we basically get the mathematicians to sit down and to use Lisp, and we give them enough time to learn Lisp thoroughly, and they come up the learning curve quite quickly, and basically we've been very, very successful converting mathematicians into Lisp programmers to the extent that they are, you know, one of my senior developers is a mathematician. The person who did the entire user interfaces for ESP, the rule-based engine, is a mathematician. So we've been very successful in finding and converting mathematicians into Lisp programmers.
Yeah. And so one more time about going into a potential customer and then talking about the fact that your whole system is built in Lisp. Now you referred to that several times in your talk, but can you one more time kind of summarize how you deal with that when you go into a potential customer?
Well, yeah, I mean, often we'll sit down, and one of the questions that happens early on is what is your program written in? And we will say, and I'll say that the program is completely written in Lisp, and I will give several reasons for it. And they might typically will say Lisp, like it's a surprise. They would, and which of course it is. I'll cite several products that have been written in Lisp, but I'll also go on to say, look, it's an ANSI standard language, right? There are plenty of programs out there that are using it. There are thousands of people who can program in it, and and it has wide industry support. I'll also point out that that many things like Python and Ruby on Rails and and the list goes on, like dandelions in your lawn, are dozens and dozens of languages that people take for granted that are just, oh, well, we're going to have those. Are we going to really have those languages in 10 years? Who knows, right? Lisp has been around for 40 years. Usually by the time I get done with my diatribe, the answer is, okay, that sounds fine.
All right. I have one more question from the audience, and that is, so if you hire a mathematician, in general, how long does the process take to get him into a reasonable Lisp programmer?
Usually somewhere in the area of 60 days, they're functional. and probably 90 to 120 days they're writing code that passes our CMMI process of peer review. So you say, well, you're paying a 90-day premium of their salary for them to learn Lisp. And the answer is yes. But the payback, when I presented you the JPL numbers, the payback is 4 to 1, right? So, would I rather have a 4 to 1 payback over a period of 5 years, or would I rather have somebody, chugging out Java? Answer, Lisp.
Okay. Well, Glenn.
And by the way, I'll just add one more piece. The same is true for using AllegroCache. Would I really want? If someone wants to come in and learn to use an ODB, an object database like AllegroCache, their time to learn it is literally days. I can't say the same about relational database like Oracle or one of the competitors. Anyway, sorry, I don't want to get on my high horse about AllegroCache. If you want me to talk at length for like 5 hours about that, please give me a call. I'll be happy to.
All right. Okay, Glenn. Well, thanks very, very much for your time. We've been now here for 50 minutes, slightly longer than we normally have. This whole lecture or talk will be recorded and made available on the France website and probably also on the 2eyes website. And Steve will send out an email and you can look at it again or send it to other people. So Glenn, thank you very, very much for this talk. We really enjoyed it here.
You're welcome. You're welcome.